The definition of a vector is to let theta be in standard position, terminating at the point xy on the circle x squared plus y squared equals r squared. Then sine theta equals y over r, cosine theta equals x over r, and tangent theta equals y over x. A magnitude of a vector is the distance from the origin to the vector. The equation for magnitude is the absolute value of the point AB equals the square root of a squared plus b squared. An example for this is the absolute value of the point 3, 4 equals the square root of 3 squared plus 4 squared, which you solve for the square root of 25, which equals 5. In this diagram, you can see that the magnitude for this problem is 5. The direction of a vector is the angle in standard position where the magnitude is used as the terminal side. To solve for direction, you always start with tangent theta equals y over x. Next, you plug in the values for x and y, then you solve for the inverse since we are trying to find an angle. The angle that you get is the direction for a quadrant 1 problem. Once again, you start with tangent theta equals y over x. Then you plug in the x and y values. Next, you find the inverse of tangent, but since this is quadrant 2, you're not done yet. Then you add 180 degrees to the number that you got for the inverse of tangent. This is because the angle that you just solved for is half a circle away from the angle we're actually looking for. Once you've added 180 degrees to the angle you originally found, you're done. Since our angle is in quadrant 2, you must add 180 degrees to the angle that you solved for it to be in standard position. Once again, you start with tangent theta equals y over x, plug in the x and y values, and then solve. Just like before, you solve for the inverse of theta and then add 180 degrees. Once you've added 180 degrees to your original angle, since it's half a circle away, you're done with the problem for quadrant 3. You add 180 degrees to put the angle in standard position. Once you've added 180 degrees, you are done for our quadrant 3 problem. For a quadrant 4 problem, you start with tangent theta equals y over x. You plug in the x and y values and solve, just like the rest of them. After that, you solve for the inverse to find theta. Then you add 360 degrees instead of 180 degrees to find the positive value for the angle. For quadrant 4, adding 360 degrees puts the angle at standard position. For all of these problems, we are solving for the positive angle, which is the distance. For all of these problems, we are able to use tangent theta equals y over x because we have a point at which the vector terminates. In this problem, it was 4, -6, and theta is in standard position. If we wanted to find the magnitude of any of these problems, we would just plug in the side lengths of the triangle into the magnitude equation, which we are able to use because of x squared plus y squared equals r squared within the definition of a vector.